Hello, I've had a question about Unit 1, Lesson 6, number 45. Two children are having a toboggan race down the frictionless hill at 30 degrees. So if this is my hill, children are 20 and 40 kilograms respectively. What's the acceleration of each child? So if we were to do a free body diagram, which is very important on this one because, again, it's going to build our equation. We have force due to gravity. What's pulling the sled down the hill? Well, the only thing pulling it down is FGX. We have a normal force. Don't want the toboggan sinking into the ground. And the normal force is countered by FGY. Now, what's nice about this one is there's no frictional force here, no FF. So it makes the math fairly straightforward. Now, they want us to determine what's the acceleration down the hill. So we can set it up with FU-ma, or unbalanced or net force. So there's our unbalanced force equation. When we look at it, there's only FGX down the slope, mass times acceleration. So there is the equation that's built from the free body diagram. That is the only unbalanced force because there's nothing opposing it. FGX, that is your mass times gravity, and it is sine of the angle. I'm going to put sine theta for the moment. Now here's where the neat thing with this is, whether you put the 20 or 40 in, it actually doesn't matter. Mass cancels out, which means for acceleration, I'll put this off to the side, for acceleration, mass does not matter. So this is very similar to the concept of if you dropped an apple and a feather in a vacuum, which one lands first? The answer is they both will land at the same time because gravity acts equally on them. Same thing here with someone going down a hill. In an ideal world, which is what we're dealing with here, so no friction, mass does not matter. So both children are going to get to the bottom of the hill at the same time. Finishing that up, we're left with acceleration equals g sine theta. So 10 sine 30, and that's 5 meters per second squared. So there's our answer to A. So therefore, each child accelerates at 5 meters per second squared. So when you look at B part, which one reaches the ground first, or the bottom first, it's going to be the same, okay? Both reach the bottom at the same time. All right, and that's an ideal condition, okay? If in the real world, obviously that's not the way it works, but then it ties into how much frictional force is involved and coefficient of friction on the slope and so on and so forth. So that's why usually people that are a little bit more mass will go down the hill a little bit quicker because they're overcoming the frictional force a little easier. But there is your solution to number 45 in lesson 6. If you have any further questions, let me know.